Hello, today we're going to talk about axes of symmetry and vertex. So let's first talk about axes of symmetry. So the graph that any quadratic function is symmetric about a vertical line called the axis of symmetry. The equations of that vertical line will have the form x is equal to c, which represents a constant or a number. So we should know that the axis of symmetry is going to lie halfway between 2 points that are across from each other horizontally. So that means that they have to be directly across from each other. All right. So let's look at two examples. So example one says, find the equation of the axis of symmetry for the quadratic functions below. So if I look at question A, I'm going to identify 2 points that are directly across from each other horizontally. So I'm going to use the x-intercepts here, because I know that my x-intercepts lie on the x-axis, which goes in a horizontal direction. So any points lying across from each other on the x-axis are horizontal to each other. So my two x-intercepts are -2 and +3. So I know that my axis of symmetry should be located halfway between these 2 points. So if I were to add these points or these x-intercepts together and then divide by 2, I will end up getting 1/2. So my axis of symmetry should be equal to 1/2. And if I were to draw that, that line would lie directly in the middle, somewhere like this. All right. So that will be the axis of symmetry. And as you can see, when we draw it, it is dividing that parabola into two equal pieces. So that is our axis of symmetry here. All right, for B, if I want to find the axis of symmetry here, I'm going to mark the x-intercept. As you can see here, we only have one. So technically, the axis of symmetry and that x-intercept will be the same. All right, so there's our axis of symmetry. And as you can see, when we draw it, that axis of symmetry is equal to 3. Now, please make sure that when we write the axis of symmetry, please make sure you write the equation, because it's actually a horizontal line. So this is x is equal to 1/2, and this will be x is equal to 3. So just make sure you write it as an x equaled equation, so that way it will be a horizontal line. All right. So now let's look at the actual equation for the axis of symmetry. So here it says, the equation of the axis of symmetry of a quadratic equation, which is in the form of y is equal to ax squared plus bx plus c, is equal to x is equal to -b divided by 2a. So this is what we use whenever we have equations. So we should know that a is going to be the number in front of x squared, b is the number in front of x, c is the constant by itself. So if we look at example 2, we know that by looking at this equation that a will be equal to 5, b will be equal to -4, and c will be equal to 3 based on that equation. And of course, they're asking us to find the axis of symmetry. So all I have to do is use this equation. X is equal to -b divided by 2a. So if I say x is equal to negative b, this is going to be negative, and b is a negative 4, so negative negative 4 divided by 2 times a, and a is 5. So if we simplify, that negative negative 4 is a positive 4, that 2 times 5 is 10, and 4/10 simplifies to 2/5. So the axis of symmetry is located at x is equal to 2/5. That is the equation of the axis of symmetry. All right, so let's talk about vertex. So a vertex is a turning point of a quadratic function, which is in the form of y is equal to ax squared plus bx plus c. There are two types of vertices of a quadratic function. We have a maximum, which means you have a high point, and then we have a minimum, which means we have a low point. Your maximum is going to occur because your a value is less than 0. And when I say a, I'm referring to the a in the standard form of the equation. And then if you have a minimum, that means that your a value has to be greater than 0. So the vertex of a quadratic function always lies on the axis of symmetry. This means that the axis of symmetry is equivalent to the x value of the vertex. The y value of the vertex, or any other point that we want to find, can be found just by substituting the x value into the function and simplifying. So let's look at this first example. Find the coordinates of the vertex of f of x is equal to negative x squared plus 6x plus 4. So I know that the x value of the vertex is equivalent to the axis of symmetry. Okay, so that means that I can find x is equal to negative b, which will be 6. And let me label the a, b, and c's. So we end up having that a is negative 1, b is positive 6, and c is 4. So when I substitute this into the axis of symmetry equation, this is going to be x is equal to negative 6 divided by 2 times negative 1. And I know that that is negative 6 divided by negative 2, which is a positive 3. So this means that the axis of symmetry, or the x value of the vertex, is located at x is equal to 3. Okay? So now if I want to find the y value, I'm going to substitute in this 3 in for x here and here. Okay? So in order to do that, and when I do that, I will have y is equal to negative x, which is 3 squared, plus 6 times 3 plus 4. So if I put that in my calculator, I will end up getting 13. So I know that my vertex is located at 3, 13. That's my vertex is. Now you can find your vertex inside of the graphing calculator. Okay? If you want to find your vertex, we know that all we have to do is graph it. So I'm going to graph the equation. So that's going to be negative x squared plus 6x plus 4. When I graph it, I want to be able to see my entire graph. Now, if you have cleared your graph probably would have looked like this, and we cannot see the actual top. So basically my y value, my y-axis is only going up to 10. So it looks like my y-axis needs to go up a little bit more. So I'm going to adjust my window. So if I press window, I am going to change my Y max. I'm going to change it to 20 so that I can go up to 20 on the y-axis to see if that gives me enough room to see. So yes, I can see my vertex nice and clear. So I want the calculator to calculate that vertex. So I'm going to go to the calculate menu. So I press second trace, and then I go and choose whether it's a minimum or maximum. The graph looked like this one. It was pointing downward. So this is a maximum. So I press enter, and then it says left bound. What it's telling me is I want to go to the left side of the vertex. So I go to the left side of it and I press enter. I then go to the right side of it somewhere and press enter, and you should see that your vertex is going to lie in between those two vertical bars. And then I press enter for the third time, and it tells me that my maximum is located at 3.00000001. And the y has to be at the 13. So x is approximately 3, y is 13. So now in order to verify what the x value of that vertex is, I can look at my table. And if you look at this table here, you can kind of see, if you look at the pattern of your y values, you're going negative 36, negative 23, negative 12, negative 3, 4, 9, 12, and then 13, back right down to where we came from, 12, 9, 4. So you see how they start repeating? You have 313 dead in the center because that 13 is in the middle of being 12 on the left and 12 on the right. So I know that that 13 has to be the middle or the high point. So that's also how I can tell what my vertex is. All right, so let's look at our last example, which is example number 2. So it says, consider the quadratic function. We have y is equal to, and I'm going to go ahead and type this in, y is equal to negative x plus 3 times x minus 2. So it says find the axis intercepts. So remember, we can use our calculator to find the axis intercepts. So what I'm going to do here is I'm going to go to my table, or actually I can actually go to second. As a matter of fact, before I do that, let me graph it so we can see the graph first. Okay, so now that I can see my graph, I can tell it where to calculate my intercepts, my x-intercepts. Those are called zeros. So if I go to second trace, I go to number 2 for 0, and I literally need to go and locate my x-intercept is somewhere here. So I need to go to the left side of it and press enter. Then I'm going to go to the right side of it and press enter. And as you can see, that x-intercept is in between the two lines. I press enter for the third time. So I see that my x-intercepts are located at negative 3, 0. And I have to find the other one. So I'll go back to second trace, number 2, 0. And then I go and locate the one on the right hand side, but it says left bound. So my left side is somewhere here. Then I go right bound on the other side of it. And as you can see, it's in between. And then I press enter again. So that's 2, 0. You should be able to also know how to find those because remember, your x-intercepts is the value of x when y is 0. So if you were to make this y value 0, you know that one of these factors will have to be equal to 0, which means x will be equal to negative 3, and x will have to be equal to 2, which is what I got here. Okay, if you wanted to solve it by factor form. So now that we have the x-intercepts, we can then find the y-intercepts. So remember, the y-intercept, that's very easy to find. The y-intercept is the value of y when x is 0. So all we have to do is substitute in 0 for x. And if we do that, we will have negative 0 plus 3 times 0 minus 2. And that will give us 6. So our y-intercept is located at 0, 6. So I'm going to graph those. So we have negative 3, 0, and positive 2, 0 as our x-intercepts, and then the y-intercept is at 6 on the y-axis. Okay, so now let's find the axis of symmetry. So remember, for your axis of symmetry, yes, it is equal to negative b divided by 2a, but the equation is not in standard form. Standard form is y is equal to ax squared plus bx plus c. It is not in standard form. So what we have to do is we can use the x-intercepts because they are across from each other horizontally. They're across horizontally. So I can use those and I can just find the middle of those two. So my axis of symmetry, if I look, it will be negative 3 plus 2 divided by 2, which is negative 1/2 or negative 0.5. So I know that my axis of symmetry is located at the equation x is equal to negative 1/2. So I can draw the axis of symmetry here. So if I were to draw the axis of symmetry, it will be at a negative 1/2, which is approximately here. And then I can draw it in. All right. So there is my axis of symmetry there. And remember, there your points when you look at your axis of symmetry, a point on the left side should be the same distance from the axis of symmetry as the point on the right side. So here we're 2.5 units away. Here we're 2.5 units away. So I can do the same thing and find me another point on the other side of that y-intercept here. All right. So now let's find the actual how high up the vertex goes. So we need to find the coordinates of the vertex. Well, remember, the x value of the vertex is already the axis of symmetry. So all I have to do here is substitute in negative 1/2. So if I go and I put y is equal to negative 1/2, excuse me, plus 3 times negative 1/2 minus 2, I can find out what that is. So I have negative 1/2 plus 3 times negative 1/2 minus 2. And I see that that is 25 over 4. And 25 over 4 as a decimal is 6.25. The vertex is located at negative 1/2 and 25 over 4. All right. So if we were to graph this, we know that 25 over 4 is 6.25, which will be somewhere right around here. So that'll be our vertex. So now all we have to do is connect with a smooth curve. It doesn't have to be perfect. Just go through the important pieces. So that's the way our graph will be sketched. Now that we have our sketch, it says state the domain and the range. So domain is x. So my x values, as you can see, is both going down on both ends, but it's getting wider. So I have all real numbers for my domain, or you can write it as negative infinity to positive infinity. Now the range is how high or how low the graph goes. So the highest point on the graph is 6.25 or 25 fourths. So we can say that y has to be less than or equal to 25 over 4. Or if you write it in interval notation, you can say we're going from negative infinity on the y-axis to a positive 25 over 4. And make sure you use the bracket so that is included. So if you have any questions, please ask your teacher and have a great day.